Welcome to Mr. Kritzinger's Maths video lesson based on regular polygons. A regular polygon is a two-dimensional figure where all sides are equal, and all angles are equal. I'm going to show you a few examples of regular polygons. First, we will start with a triangle. Okay, so any triangle where all the sides are equal and where all the angles are equal is a regular polygon. Next, we will look at squares. So a square is a regular polygon because all the sides are equal as well as all the angles. Next, we can move on to a pentagon. A pentagon similarly has 5 sides and 5 angles. So in this case, we have 1, 2, 3, 4, 5 sides and 1, 2, 3, 4, 5 angles that are each equal. We can continue to 6 figures, 7-figured and 8-figured shapes, like for example an octagon is an 8-figured shape where each side and each angle are equal. And so what we can do with polygons, regular polygons, is we can find the middle point of each shape. For example, we can find the middle point of the square. Then from each vertex we can draw a straight line that meet in the middle as such. From this vertex, from that vertex. So this will divide the square into 1, 2, 3, 4 triangles, and each of these triangles are congruent, which means they are exactly the same. The sides of each triangle is the same size, and so this triangle side length is equal to this triangle's corresponding side length. This side length is equal to that side length. And the same applies for the angle. So basically the matching angles and the matching sides will be the same. We can do the same for the other shapes. For the triangle, we meet from each vertex to the midpoint. We can do the same for the pentagon. So we have a midpoint and they all meet at the midpoint, and then it should give 1, 2, 3, 4, 5 triangles where each triangle is congruent. In other words, each triangle is exactly the same. Each triangle has for each corresponding side and each corresponding angle the same sizes. So what I'm going to do is I'm going to use a square as an example of a polygon and do a few calculations and indicate a few further points of importance. Before we move on, we know that the sum of the angles around a point adds up to 360 degrees. So in other words, if we take for example this pentagon, this angle here plus this angle here plus the angle here plus the angle here plus the angle here each have to add up to 360 degrees. So the 1, 2, 3, 4, 5 angles that meet adds up to 360 degrees. So to get one of these angle sizes, we will divide 360 degrees by 5. Okay, so 360 degrees divided by 5 will give you 72 degrees. So each of these angles are in fact 72 degrees. In general, we can say for any polygon that we can divide 360 degrees by n, where n is the number of sides, to determine the angles around the point. Okay, so let's move on to our square example. Okay, so here's our square example. What we have is a square where each of the sides are 4 centimeters. So we are given square AB, CD, and the lines from the vertices meet up at point E in the center. What we also did is we extended line DA to form a line FAD. We extended line CD to form a line CDG. We extended AB to form I, and we extended BC to form H. So we are going to work with this square as an example of how to do some of the calculations. Okay, so now what we are asked is to calculate the sizes of the angles of triangle EAB. Okay, so now let's see. Triangle EAB is, here's E, that's the midpoint, A, B. So we need to calculate the size of each of these 1, 2, 3 angles. Okay, so first of all, we can calculate what this angle is around the midpoint, because we know that the sum of the angles around the midpoint should give us 360 degrees. So we can say 360 degrees divided by the number of sides. We know a square has 4 sides and there are 1, 2, 3, 4 lines that meet at the middle. So 360 degrees divided by 4 will give us 90 degrees. So we can in fact say that angle AEB equals 90 degrees. Okay. Next, we can calculate what the size is of each of angle A, D, E, and C. Okay, because we know that all the angles need to be equal for each of those. So angle A, angle D, angle B, and angle C are all equal, and we know that they are all 90 degrees. Okay, so another way that we could have calculated it is to say that the sum of the angles of a triangle equals 180 degrees. We have now 1, 2, 3, 4 triangles. So we could say 4 times 180 degrees gives us 720 degrees. So you can say 4 times 180 degrees give us 720 degrees. But we can say, from what we calculated previously, that the angles around the midpoint add up to 360 degrees. So we have to subtract these 360 degree angles just to get the sum of the angles of our regular polygon. Okay, so what is 720 degrees minus 360? Yes, you are correct. That is 360 degrees. So therefore, we can say we have to divide 360 degrees by 1, 2, 3, 4 angles. So 360 divided by 4 is 90 degrees. So we know angle A, angle B, angle C, and angle D each equals 90 degrees. Okay, but now these lines split these angles in two. So therefore each of the other angle are 45 degrees. So this angle here and this angle here is 45 degrees. So in other words, angle EAB equals 45 degrees and angle ABE is 45 degrees. So let's move on to the next question. The next question asks that we need to construct the square. Okay, so we already calculated in A that each of the angles are 90 degrees. So so we are going to have to use that information. We know obviously that the length of each side is 4 centimeter, so we can start off with a 4 centimeter side. Okay, now I'm going to extend it. Let's just start with something a bit larger than 4. I'm just going to make it 8. I'm going to move a little bit to the right. Okay, now I'm going to call that point B. Now I'm going to measure 4 centimeters. And we are going to call that point C. Now we know that each angle should be 90 degrees. So we can simply use our protractor and measure 90 degrees. So now we can draw a line that meets up again. And we can do the same here. We can measure 90 degrees and draw a line to connect those 2 points. Okay, and we know this line needs to be 4 centimeters. So we can mark off 4 centimeters. And we can mark off 4 centimeters. And now again we can measure from the point that we marked off the 4 centimeters 90 degrees. Okay, it will just help if I have my protractor the right side. Okay, so we need to connect those points. Okay. So now we can mark our points. So this is BC, D and A. Yeah, so each of them are 90 degrees. And we can now extend these lines to form the angles, or the outside angle, the exterior angle. So we call this F. And we call this I. We have this one as H here, and then this one here is G. Let's make it here G. Okay. So now we have constructed our square. Next, we are asked to extend the sides as shown and then determine the sum of the exterior angles. Okay, so we already extended the angles, so we did already the first part of the next question, which was extend the sides of the as shown and then determine the sum of the exterior angles. Okay, so let's fill in here what we already know. We already know this angle is 90 degrees. We already know this angle is 90 degrees. We know this angle is 90 degrees, and we know this angle is 90 degrees. But what else do we have? We know that the sum of the angles on a straight line adds up to 180 degrees. So therefore, the 90 degree plus this angle here should give 180 degrees. 180 minus 90 is 90, so this should be 90 degrees. And in fact you will see it will work for all these cases. 90 plus what gives 180? 90 degrees, sum of the angles on a straight line. So in fact each of these exterior angles will be 90 degrees. And we have 1, 2, 3, 4 of these exterior angles. So the sum of these exterior angles will simply add up to 360, which is 90 degrees times 4. So that takes care of question C. Now we are asked what the sum of the interior angles are. And we actually already calculated it previously to answer the question that was asked for the first part, where we had to calculate the sizes of all these angles that form triangle AEB. Okay, but I'm going to show you another way that we could calculate it. If you can recall correctly, for this example we first said that the sum of the angles around the point is 360. Then what we did is we determined that there were 1, 2, 3, 4 triangles. We know a triangle is 180 degrees, so we took 4 times 180, which gave us 720, and then we subtracted the 360 to get to 360 degrees. Okay, so now I'm going to show you a different way of how we could do it. Let's imagine that, let's start off with a triangle, a regular polygon triangle where all the sides are equal. If we take one of the angles, let's say this angle here, to how many vertices can we draw a line? We can't. There's already a line here to that vertex, there's already a line here. So it's just a triangle. We know the sum of the angles of a triangle is 180 degrees. So we have 3 sides and it is equal to 180 degrees. Let's move on to a square. All the sides are the same, all the angles are the same. Now let's take any one of these angles, let's say this one, and we see to how many vertices we can draw a line. 1. It's the only one. This one is already connected, this one is already connected. So we can only add 1. So we have 1, 2, 3, 4 sides. And we now have 1, 2 triangles. So we have to multiply 2 by 180, and guess what? We get 360 degrees again. We can do the same for other shapes, like a pentagon. 1, 2, 3, 4, 5 sides that are supposed to be equal if you roll it correctly. and 1, 2, 3, 4, 5 angles that are the same. Let's take again one of the angles. We can draw it to that vertex, and we can draw it to this vertex, but this and this one is already connected. How many triangles? 1, 2, 3. So we have 5 sides and we have 3 triangles times 180 degrees, which gives us 540 degrees. I hope you can see the general formula here. Here we have 3 sides, 1 triangle, 4 sides, 2 triangles. Okay, so the difference between the sides and the number of triangles are 2. The difference between the number of sides and the number of triangles are 2. Guess what? 5 sides, 3 triangles. Again, a difference of 2. So in general, we can in fact say that we can take the number of sides of the polygon, regular polygon, subtract 2 and multiply by 180 degrees, and we will get the sum of the interior angles. This was again quite a long journey, and Mr. Kritzinger is signing off. Goodbye.